Hello everyone, this is KINGSINE. In the heartbeat of modern power grids, overcurrent protection acts as the first line of defense against catastrophic failures. But how do we ensure its reliability? That's where overcurrent test modules become indispensable. For example, verifying 20 amps per 12 milliseconds trip functionality relies on high-precision plus or minus 0.05% current injection combined with microsecond-level precision timing measurement. These dual-technique rigor elevate relay certification beyond datasheets to field-proven security. Let's begin by configuring the overcurrent protection module within our test object. First, choose the specific element type we want to test from the 5 options: phase-to-phase, phase-to-ground, positive sequence, negative sequence, or zero sequence. Use the Add and Remove buttons to create or delete elements corresponding to our selected element type. Crucially, only elements where the Enable checkbox is ticked will be included in the actual test. Let's move on to element settings. Double-click within the element cell to assign a descriptive name to our element. Choose the time characteristic. Here in the element characteristic we select the desired definite time and inverse time from the curve characteristic library. This library offers standard curves, predefined curves, and user-defined curves. Standard curves includes definite time and normal, vary, and extremely inverse time options. Predefined curves features a comprehensive collection of inverse time curves compliant with IEC, IEEE, ANSI, and various protection manufacturer standards. User-defined is where we can import curve data from external sources in .xml format. After we choose our ideal test curve, click Select. Let's move to the settings below, where we can manually adjust the coefficients in the curve formula to meet specific testing requirements. Here, we can also see the preview of the characteristic diagram and adjust the display range for time limits within the boundary settings, allowing us to expand or reduce the visible range as needed. And let's back to the pickup current value. This is where we set for the current level, expressed as a multiple of the rated current, at which the protection element initiates its trip sequence. Move to the trip time setting. For definite time curves, this is the fixed trip delay. For inverse time curves, it defines the operating time at the chosen pickup current multiplier. Direction. In this section, we can configure the directional settings of the relay. When we are testing directional overcurrent, we need to first go to the relay parameter, in directional behavior, where we enable the directional, and then according to the actual PT-CT connecting method, we select between online or on busbar. And then we back to element, we set direction as reverse or forward for specific elements. In the lower section of the interface, we can set the reset characteristic. When we turn the reset characteristic off, no reset time defined. Definite time, in here we can fix reset time for all shot points. Inverse time, automatically calculating the reset time in seconds. Except for setting all the parameters one by one, we can save time by importing a configuration file to automatically set up these parameters to the test template. If you're not familiar with using test templates or importing configuration files in KRT software, this is where you can find our previous tutorial videos. Real-time preview of generated characteristic curves. This feature allows us to preview the overcurrent protection characteristic curves in real time after adjusting parameters, enabling quick visual assessment of the settings. Additionally, the KRT allows users to set tolerance ranges for current and time test results in relay parameter section, which ensures testing accuracy align with protection requirements. By fine-tuning these parameters, we can optimize the relay's response characteristics and overall reliability. Next, we'd like to conduct a practice test to help you better understand the full testing process. The test point interface enables rapid fault localization to add test points by checking current, angle, and fault type. Also, KRT supports simply configure the current range, for instance start, end, step, select fault type and angle. The system auto-generates qualifying test points, which are added to our test list with one click of Add to Table. What's more, we can also click directly on the characteristic curve to add test points. The KRT system automatically captures all parameters such as current, angle, etc. at that location. This visual method is faster and more accurate than manual entry. The parameter settings allow easy configuration of test timing including pre-fault duration to establish steady-state conditions, adjustable fault intervals, and maximum fault application time for protection testing. Additionally, fault voltage allows configuration of fault voltage magnitude during overcurrent fault simulation. Furthermore, during overcurrent testing, load current simulation can be applied to verify the sensitivity of directional overcurrent protection under load background current conditions. After parameters are all set, let's proceed with the actual test verification now. After completing all tests, we can manually evaluate the results as passed or failed, then customize the report in settings by adding descriptions, company logo, and selecting the long format to include characteristic diagrams for clearer visualization. Simply select the test object in Test Center to preview the report, and once verified, we can save it as RTF or PDF. Thanks for watching.